Hello, and this video is going to be on lesson 2.1, graphing absolute value functions. Alright, so absolute value. Now, we may have to remind ourselves what is the absolute value of a number. And let's take a look at this first one, the absolute value of -2. Now, we're going to be talking about the absolute value function, and this function is actually, I like this function because it's an optimistic function. But what do I mean by optimistic function? Well, let's take a look at the first few answers, and then I'll let you know why I call it the optimistic function. So remember, the absolute value of a negative number, it makes it into a positive number. So if we have a -2 inside the absolute value, it comes out as positive. So if you have something negative, it turns it into a positive. If we have an absolute value of -5, that becomes +5. And what about an absolute value of a positive number? Well, if it's positive, the absolute value keeps the number positive. And now, this is why I call it the optimistic function, because it takes something negative and turns it into something positive. And if it's already positive, it keeps it positive. So this is a very nice function. I like this function. And so if you take the absolute value of any number, you're always going to have a positive number. Okay, again, we call this the absolute value function. So going all the way back to our function cycle, we want to go from the function into a table form. So again, if we take the absolute value of -8, that comes out as +8. Absolute value -4 comes out as +4. Absolute value of 0, well, 0 is not negative nor positive, but the absolute value of 0 is going to be 0. Okay, now again, if we have the absolute value of a positive number, it keeps it positive, so that's 4, and then we have 8. Alright, let's go ahead and graph these points, these ordered pairs. So going from a table, we're now going to the graph, following that function cycle. So -8, 8, right there. -4, 4 is right here. 0, 0, 4, 4, and 8, 8. Let's go ahead and connect these points and take a look at that. Here is the graph of the absolute value function. Now, what does this shape look like? Well, the first instinct that students tell me is that it looks like a V, but since this is the optimistic function, I like to tell my students that this looks like a peace symbol. So if you hold out 2 fingers, you're holding the peace sign. So I like this function a lot. Okay, so what we're going to do is we want to look at the different transformations of the absolute value function. And what we worked on was a worksheet that contained this information. So here again, this is the absolute value function. We're not adding, multiplying, subtracting, or dividing by anything. It's just simply the absolute value of x. And so this is called the parent function. It is the function that we start with at the very beginning. And one thing I want to point out about this absolute value is that the vertex, the point where the lines meet, is going to be at the origin. So the vertex is always going to start at the origin for the parent function. So as you can see, all of these graphs here have the parent function in black. Now what we want to do is look at all the different transformations of the absolute value function and see and take a look at how does looking at all these equations right here, how does each of those change the absolute value function? So if we look at this, here's our parent function, and we can see that it translates it up 5 units. Now, two very important things we want to note here. Does the vertex change? Well, the vertex starts here, always with the parent function at 0, 0. And notice that it moved up 5 units. So in this case, the vertex does change. It changes. Now, does the shape change? Notice that the shape stays exactly the same. All we're doing is moving the function up 5 units, so the shape is going to stay the same. Okay, let's look at this next function. Notice here we're subtracting outside the absolute value. Here we're adding outside the absolute value. So if we're subtracting outside, this is a translate down, specifically 5 units. Notice again here, the vertex moved down 5 units, and so the vertex is changing, so it changes. And what about the shape? Again, the shape stays exactly the same. Alright, taking a look at this. What is the difference between subtracting 5 here and subtracting 5 here? Well, here the 5 is on the outside. We're subtracting 5 on the outside of the absolute value. Here we're subtracting 5 inside the absolute value, right next to the x, right after the x. So that matters a lot because we call this translates to the right. So here the vertex is also changing. It changes and the shape stays the same again. Again, the difference between this and this, we're adding 5, but here we're adding 5 on the outside of the absolute value. Here we're adding 5 inside the absolute value. So that means that looking at the graphs, we can see that the vertex changes and the shape stays the same. Now remember when we had reflect over the x and y axis, when we're reflecting over the x axis we have the negative on the outside the absolute value in this case. Take a look at this. Is the vertex changing here? So the vertex for the parent function is this, and then when it reflects over the x-axis, the vertex stays exactly where it's at, so it stays the same. Let's take a look at the vertex here. Looking at this, we see that we have the negative on the inside of the absolute value, so it reflects over the y-axis. Here the vertex again stays the same. It's actually a mirror image across the y-axis, so it actually gives us the same exact function. Okay, let's take a look at verticals. This next transformations here, we have a vertical stretch factor if we multiply by a number on the outside of the absolute value. Again, take a look at this. Is the vertex changing here? Nope. It's actually staying the same. But notice here again our parent function is in black, but the function in red is a transformation. The shape is changing here. And when you take a look at all these other transformations, we can see that the vertex stays the same, but the shape is changing. So it changes. Stays the same, changes, stays the same, and changes. Alright. So one of the important things that we want to do using this is we want to use this to help us find the transformations, and we want to be able to graph that transformation. So going from the parent function, how is the graph going to look like after those transformations? Now this table here is just a really handy chart to help us find 3 points of the vertex. So let's take a look at an example first of all in order to see how we can use this paper. So C is asking us to graph the graph of g of x, which is equal to 1 over 4, the absolute value of x, will be the graph of f of x compressed. So notice here we have a number outside the absolute value, and specifically this is a fraction that is between 0 and 1. So this is a very important condition. It has to be between 0 and 1, which is, in this case, it is. Whenever we have a fraction outside the absolute value, here we see this right here. Notice that here we have the fraction inside the absolute value, so we're not looking at that one. We call this a vertical compression factor of 1 over 5. So it's compressed vertically by a factor of 1.5, 1 over 5. Or in this case, it's 1 over 4. Alright, now how we found the transformation, so we identified we just only have one. How am I going to graph this on my grid? Well, this is where this table comes in. If we have a vertical compression by a factor of 1 over 4, we can take this table and look at where we see a vertical compression. So vertical compression is on this side, and the operation that it tells us is to multiply by a. So what I'm going to do is I'm going to set up a table here, and I'm going to use the point 4, 4. So if I use the point 4, 4, I want to see what is going to happen to this point, this ordered pair, after I make the transformation. So what it says here to do is I'm going to multiply by a. In this case, a is 1 over 4. Now it tells me to multiply on the y to multiply the y coordinates. So I'm going to multiply by 1 over 4, and since I have no operations here, I drag the 4 down. 4 times 1 over 4 is basically 1. So my new point 4, 4 is now going to become 4, 1. So here I have a new point of how my transformation is going to look like. Now, does a vertical compression change the vertex, or is it going to stay the same? So let's take a look at this. A vertical compression makes the vertex stay exactly the same. So let's go ahead and leave the vertex where it's at. And to find the other point, we can again take another point from our graph. This time let's take -4, 4. You can you can pick any point from the parent function, and we're going to use this exact same calculation here. So we didn't have anything on the x coordinate to multiply by, so we have -4 still. And this time on the right hand side we have to multiply by 1/4, so this is going to be 1 again. Same thing that we have here. And so we're going to go -4 to the left and up 1. And when we connect these dots, that is going to give us our transformation. There we go. So that's how we're going to use this table and these notes right here to find the transformations of our functions and to be able to graph it. So let's take a look at this example right here. So let's take this example. Notice that here we have not just one transformation, we have many different transformations. Again, our parent function is this. So every single little thing here, we're adding 3, we're adding 1, we're multiplying by 1/2, and we have a negative. All of these different things that I circled represent a single transformation. So let's start from the left and work our way to the right. So here, first of all, we have a negative. Let's figure out what is that negative telling us to do. First, well, this negative is inside the absolute value. So it's inside the absolute value. And since it's inside the absolute value, it's going to be this right here. Again, the vertex stays the same, so it's called reflected over the y-axis. So I'm going to go ahead and write. I'm going to use red for this one, and it's reflected over the y-axis. And I want to make a note. Is it going to change the vertex? Nope, it's going to stay the same, so I'm going to write same. Alright, the next thing I want to look at is my 1/2. Now this is a fraction between 1/2 is between 0 and 1. So I'm going to go ahead and look at my transformation sheet, and again, this is inside the absolute value. It's in between those two vertical lines. Where do I see a fraction in between those two vertical lines? Well, it's here. It's a horizontal stretch. So I'm going to write horizontal stretch. Factor of what? I have to look at this. Notice in this example, the factor is what is in the denominator. So 1/5, we flip this 1/5 and it basically becomes by a factor of 5. So that is very important. So here we have a horizontal stretch factor. Since we have 1/2, we're going to flip that 1/2 and it becomes 2/1, which is basically 2. Again, let's take a look at here. Does the vertex change? Nope, here it stays the same. So let's go ahead and write same. Alright, the next thing I want to do is look at this +3 +3. Now we are adding 3 inside the absolute value, so we need to look for a transformation that adds 3 inside the absolute value. Here it is. So in this case, we're translating to the left not 5 units but 3 units, and notice here the vertex changes. So we're translating to the left 3 units, and we want to make a note that the vertex changes. Okay, and finally we have +1. +1 where it's outside the absolute value, outside. And let's take a look at where we see a number adding outside. Here it is. It's translating up. Taking a look at the graph here, the vertex changes. So in this case, we're gonna translate up 1 unit, and the vertex changes. Alright, those are our transformations right there. We have 4 different transformations. So what we want to do is take these transformations and begin graphing our 3 points. Now the very first point you want to graph is going to be the vertex, and the only transformations you're going to look at are the ones that change the vertex, and this is why we made the note here. So the same is reflector of the y-axis is going to stay the same. Horizontal stretch factor stays the same. These 2 last transformations are going to change the vertex. Translates left 3 units and translates up 1 unit. So remember, from the parent function, we're going to start at the origin and just follow those 2 instructions. So we're going to move to the left 3 units, 1, 2, 3, and up 1 unit. Just by following those instructions, I found my vertex really easily. So there is my first point. Now what I want to do next is I want to find my other 2 points. So here's my vertex. How's my function going to look like after that? So that's where we have to use our 2 tables here. And what I want to do is, give me a second here, I want to use this right here, this chart. This is going to be very helpful. Alright. So again, here are my transformations. Now, here's what we want to do. We want to go through each of these transformations one by one and use this chart to tell us exactly what is going to happen to where we're going to find our next 2 points. So notice, remember, as you can see very faintly here, here's my parent function, and if you don't know, we need to use 2 points. So the first point we're going to use is 1, 1, which is exactly on the parent function, going all the way back to when we graphed our function. The parent function has the points 1, 1 and -1, 1, and so we can use any points on the parent function, but by default we're going to use those. So here I have 1, 1 and -1, 1. Now the first transformation I want to look at is reflected over the y-axis. Taking a look at my chart, here I see that we are reflecting over the y-axis, and the instruction that it tells us to do is to multiply by -1. So I'm going to go to my table. Very important, it says to multiply the coordinate x specifically. So on each of these I'm going to multiply by -1 on the x coordinate side. Okay, so that is done. The next thing here is we have a horizontal compression factor of 2. So let's see what that says for us to do. Horizontal compression is right here. It says to multiply by a. In this case, a is the factor. So a is 2. Now it says to multiply on the x coordinate. So on the left hand side, we're going to multiply by 2. Okay, so that is done. Next thing to do is translate left 3 units. So let's look at our chart here. Translate left. Here it is. And it says to subtract h. Well, what is h? That's the number that we're translating by. So in this case, we are subtracting 3. And remember, this is on the x coordinate. So I'm going to go ahead and put minus 3. Subtract 3. Subtract 3. Alright, and we have one more transformation. It says to translate up 1 unit. So looking at my chart, translate up is on the under the y coordinate side, and here it says to add k. And so k is what we're translating by. So here we're adding 1 this time. So adding 1 on the y coordinate side. So we went over all of our transformations. Now we can go ahead and begin to calculate. Starting with 1, 1, we're going to go through each of these calculations and figure out what our answer is going to be. So 1 times negative 1 is negative 1. Negative 1 times 2 is going to be negative 2. And negative 2 minus 3 is negative 5. So we're done with the x coordinate. Now we're on the y coordinate side. And this, we just have one operation, so 1 plus 1 is basically 2. And as you can see, these calculations, which come from our transformations, we started with 1, 1, and our point ends up being at negative 5, 2. So let's go to our graph. Again, here's my vertex. Negative 5, 2 is going to be right here. And guess what? I can go ahead from my vertex, draw my line that goes exactly through negative 5, 2. So I know that that is what my vertex is going to look like. Now we have 2 points. We need 1 more. And that's where we use this other table to find my final third point. Notice here on the right hand side stays the same. It's basically 2. But this time we have negative 1. So let's go ahead and calculate this. Negative 1 times negative 1 is going to be positive 1. 1 times 2 is 2. And 2 minus 3 is negative 1. And so here is my third point. Negative 1, 2. Let's go ahead and go to our grid. Negative 1, 2. Here it is. And there is my other line. So as you can see, here is my parent function in red. And this, going all the way back to my function, here's the function right here. This function, through all the different transformations, created this new absolute value function right here. And we have those 3 points. Alright, so just to recap, we started with the function right here. We found the transformations using our notes that we have here. It was very important to know if the vertex changes or not. And once we found the transformations, we used this table right here. Well, we took the last two that changed the vertex to find the vertex, and then to find the last 2 points, we used this table right here to find the last 2 ordered pairs that we needed to graph our function. And notice we used 1, 1 and negative 1, 1 that lie on the parent function. They lie exactly on the parent function, and we use those 2 points to tell us where our 2 new points are going to be at, which were negative 5, 2 and negative 1, 2. Okay, so that is what we did for lesson 2.1. Thank you for watching.